Good morning to you. I welcome you to our 16th lesson in integrated science. I hope you're doing well. You can check the scoreboard for you, the scores of your previous assignments. Now, I'm saying that watching the video will help you understand the lesson better. So do not be in haste to or do not rush through the video or stop on the way. Make sure you watch the video to the end to fully grasp the concepts. Now, gradually we are edging towards the end of this topic. We ran through the properties of light, rectilinear propagation of light, reflection of light, and we're ending the topic with refraction of light. Refraction of light. And by the end of the lesson, you should be able to explain the term refraction of light accurately. To demonstrate reflection of light in water or glass using diagrams. You are advised to take this lesson seriously. So by way of revision, we touched in our earlier lesson on laws of reflection. We also touched on diagrams to illustrate how image is formed by plane mirror. Okay. In our lesson today, we want to learn about refraction. What is refraction of light? Now, looking at the diagram carefully, we will observe that a pencil partially immersed in water or glass of water is seen bent. The question is the pencil really bent in the water? The answer is no. What actually happened? That is the focus of our lesson. So this picture will be explained further or understood after looking at the concept or the basic idea about refraction of light. So we'll get back to this picture pretty soon. So this is a practical demonstration of refraction. Now, what then is refraction of light? Remember, we learned reflection of light as a bouncing back of light's ray as it strikes a polished surface. What about refraction of light? So refraction of light is a change in direction of light as it travels from one medium to another medium of different optical densities. One medium is air compared with another medium, which is either glass or water. I want us to take the definition again. And note some key expression in the definition. Reflection of light is the change in direction of light ray as it travels from one medium to another medium of different optical densities. One medium is air compared with another medium, which is either glass or water. Now, in this definition, we'll note the first expression, change in direction of light. There's a change in direction of light. Why? Now, the change takes place as the light travels from one medium, which could be air or glass, to another medium, which could be air or glass or water. And these two media are of different optical densities. Their densities are different. In other words, the compartment of the particles are different. That is why there's a change in direction of the light ray. This is explaining why the pencil has bent. Again, further explanation will be given as we move on why the pencil is seen bent in the water. So we're saying that one of the medium is usually air, which is less dense, and the other medium, the light enters, or from which the light is produced, is either glass or water. Glass or water are having greater density than that of air. And because of the differences in densities, as light travels from one medium to the other medium, there will be a change in direction of light. Light will no longer travel in a straight line, as we discovered under rectilinear propagation of light, where we considered only one particular medium or uniform medium. But in this case, we're looking at two media, one having a different optical density than the other. Now, why do we use the word optical? The word optical is used here to mean that the media through which the light passes are transparent. They allow lights to pass through them. That's why we use the word optical. To note why we use the word optical. Well, now, let's move on to look at the second objective, diagrams of refraction of light. Diagrams of refraction of light. At this level, I expect you to be critical about whatever I will say about the diagrams. Failure to go by these instructions in answering questions regarding the diagrams of refraction will cause you to lose significant marks. So please, be sure to follow me as I explain the diagrams. That's why I pointed out earlier that watching the video gives you an advantage in fully understanding the concept better than just mere reading and watching the diagrams. Very good. Now let's take each diagram one after the other and know what it entails. We'll start with the one on the left. Now, if you look at this diagram compared with that of the diagram of reflection of light, they share some similarities and yet there are some differences. So let's look at some similarities between this diagram and the diagrams of reflection of light. So let's take this one. And the reflection, we have normal. Here too we have normal. That's the imaginary line that is at a right angle with the surface. We also have incident ray, also found in the diagram of reflection, incident ray. And the point of incidence is also here as in the diagram of reflection. Alright, then we also have I. I here represents angle of incidence, the angle between the incident ray and the normal. Now let's look at some differences. Now, unlike the reflection diagram, the refraction diagram has an interface. This is not a mirror surface or polar surface, but an interface. And this interface is a boundary between the two media. So in this case, here is glass or water, and below is air. So the boundary between the two media of different optical densities is what we call the interface, I-N-T-E-R-F-A-C-E. Another different feature of this diagram is the R. Now the R here, as in the diagram of reflection, speaks of angle of reflection. Angle of reflection. But no, here it is called angle of refraction. So even though they have the same symbol R, it means different thing altogether. So now, having looked at the differences and features, let's move on to the explanation of the diagram. So we're taking the first diagram. Here, a ray of light is traveling from glass to air. So this light is cast through the glass, and upon reaching, this is the outer part of the glass, and this area is air, the air. So we are saying that as the ray of light moves through the glass, it is called incident ray. And when it hits the interface, as it enters air, it will divert, or the direction will change. Now the direction will change away from the normal, away. So in effect, the angle of refraction will now be bigger than the angle of incidence. Let's illustrate. Assuming you are wading or moving your hand in a bucket of water, you realize that the thickness of the water or the density of the water prevents free movement of your hand. So that represents the small angle of movement in the water, as in the glass at the top here. But as soon as you bring the same hand outside the water and wave it in air, you realize that this time around you enjoy free movement of the hand. So there's a wider spread, or there's a wider angle of movements with your hand in the air. So take note of this diagram carefully. So a ray of light traveling from glass to air will have a smaller incident angle but a greater angle of refraction. And this is a feature that I will beg you to note. Or if this one is not produced for a ray of light from glass to air, it will mark down. It will mark wrong for you. You can see. Now let's move on to the second diagram. This second diagram is opposite to the first diagram. It's opposite. Now what's the difference? Here the incident ray is from the air. So light travels in the air first. So you can see the angle of incidence. Now upon reaching the interface and at the point of incidence, when it enters the glass or the water, because the glass or the water is having higher density than air, the refracted ray will now be towards the normal, towards. So it becomes smaller. Like someone who is running on the shore or in a beach sand into the water. You realize that he runs quite freely on the shore until he gets into the water, where his speed will decrease, where his movement will be restricted or limited. So that's how this diagram illustrates that. So again, the angle of incidence of the light ray in air is bigger than the angle of refraction in the glass. Again, look at the refracted ray. It moves towards the normal. But in the other diagram, it moves away from the normal. Please take note of these differences. If you don't draw the diagrams as you see it this way, you'll be marked wrong. Hope you are clear. So take your time and go over the video and or the lesson notes to fully understand the concept. Please, when the instruction comes, note what they say or the instruction they give to draw the correct diagram at the right place. By way of summary, today we touch on the definition of refraction of light, and then we'll look at diagrams illustrating refraction of light from air to glass and from glass to air, or from air to water and from water to air. Now you can see the assignment system. As I indicated, you must re-watch the video if you have not fully grasped the concept to fully understand the concept in order to do the exercise or the assignment correctly. So we are supposed to define refraction of light. Number 1. Number 2, draw diagrams of refraction of light. A, the light traveling from air to glass. Look at the direction. Air first, then glass. So it means the incidence ray is in the air. Then the refracted ray is in the glass. So draw the correct diagram and label it for A. B, from glass to air. From glass to air. So the light ray is traveling from glass to the air. Glass first before air. So let's note the instruction and do the correct thing. Do not deviate with this. Alright. Note the time is fast spent. Thank you for your patience. Do the exercise in time and submit it. Have time and go through all previous lesson notes for your exam. Till we meet again. Bye bye.